Good afternoon, everyone. I think we're going to go ahead and get started. We do still have some people logging on, but we got a few housekeeping things, so I'm going to go ahead and go through those. I'd like to welcome you to this afternoon's webinar on Introduction to our new Versa Headspace Analyzer. My name is Tammy Reller. I know many of you that are on the line, so many of you are familiar with me. I am the Application Specialist and also the Headspace Product Line Manager. Today you're listening to the webinar through your computer speakers. If at any time you have a question, please feel free to type it in the chat box that's located on your screen. I want to make sure that we leave enough time at the end for all Q&A for any question and answers. So if you would like any time throughout the presentation, you may type in a question that you may have, but I'm going to wait till the end of the presentation to answer those questions. The webinar is being recorded and will be available on our website for downloading in about another week. So if you feel ambitious and want to listen to it again, or if you have other people within your labs or in companies that were not able to attend today, they will be able to get to this webinar within the next week or so. At the conclusion of the webinar, there will be a pop-up window with a survey. We ask that you please take a few minutes to answer these questions. It helps to give us feedback on these webinars and also to improve on them and figure out what other topics that you would like to see in upcoming webinars and seminars and such. So today I'm going to go through and we're going to talk a little bit about the new Versa, which is our new Headspace analyzer that we introduced in October, just a few months ago. And we're going to be talking about the overall features of that, and we're going to look at some of the specific applications that can be done on this analyzer. There's some very nice features to it, especially one being the size, two being the value that you get for that size. So without further ado, we're going to go ahead and move on. So to give you a little bit of overview on how we go about designing a product, years and years ago, we all used to sit in a room in sales and marketing and R&D and engineering, and we'd all say, well, you know, what's the next greatest product that we want to come out with? And we'd put together a conglomeration of ideas, and we would come up with a list of specifications, and it's kind of build it and they will come. And TechWire has taken a new approach to design and engineering where we actually go out and we take some from marketing, some from sales. We put a team together, service, and then we also have engineers that go out and we interview the customers. And we talk to many different customers in their particular targets. So for Headspace, the primary market we were looking at the time was a smaller capacity unit in order to fulfill the USP 467 pharmaceutical market for doing residual solvents. There was a need, both domestically and internationally, for those that had, you have very large pharma companies that may have higher sample capacities, such as what we use with the HT3, where they needed maybe 60 positions and 10 platinum positions where they could heat enough samples at one time. But you also have a lot of smaller generic pharma companies, and we're going to talk about many other applications that the Versa is targeted towards. But originally, this was a partnership and a strategic plan that we worked with another leading GC manufacturer to target this market and to be able to sell into or for customers, pharmaceutical customers, that maybe didn't need quite the capacity of the HT3. So the way that we go about designing a product is we do a customer interest. We go out and interview the customers and ask everything from sample size to sample capacity to size of the unit. What are the linearity requirements? What are the RSD requirements that are needed? And we interview a whole plethora. For the majority of this, the interviews were done in India and Korea. And then once we do that, we come up with the idea for the unit, we come up with suggested specifications, and then we test that in-house. Once we get to a point, we move to a beta phase, and then we engage customers to actually run their methods in their laboratory on our beta units. For this particular unit, we actually had 5 units out in the field. So the first one was at Phenomenex in Torrance, California. I'm sure a lot of you are familiar with them. They're a very large column and sample consumable supplier. And they have a lot of experience with running the USP 467 residual solvents method. So we used them, and they are still running some data for us. We placed 2 units at Shimadzu in India. We placed 1 at Shimadzu in Singapore and 1 at Shimadzu in China. For those of you that might not be familiar, in China they have a very strong interest not only in the pharmaceutical market, but also in the environmental market, much to the effect that we use purge and trap for drinking water and surface water analysis for VOCs. They use Headspace more over there in order to analyze these compounds. So we took the feedback from all of these sites and we incorporated most of those changes in the final production unit. Now what that means is that TechMar alone is not just coming up and saying these are the specs that we think that the market, is really wanting or that the customer wants in this. It is actually coming from the customer, and it is also coming from other distributors or manufacturers, reps, or anything like that will be selling the product. They all had feedback into this. So it was a complete collaboration in order to get to this final product. So out of that initial customer interest, this is a summary of some of the specifications that we came up with. The sample capacity for this smaller volume unit or smaller capacity unit really didn't need to hold more than 20 samples at a time. Remember, we're trying to target maybe those, they may not have as big a budget, or they just might be a smaller pharmaceutical company that may run 10 to 20 samples a day. The platinum capacity didn't need to be more than 1. For most of the USP 467 methods, they're running about an hour runtime, and with the number of samples that they were running, this was sufficient. The standard sample vial size was requested to be 22 ml. It didn't need to go any higher than 200 degrees, and as you can see, we move on down the line. It has the percent RSD. For the USP, it's a requirement of 15% or less, but we were getting a request for 5% or less, but preferably 2% or less on the class 1s, 2s, and 3 compounds. This is a picture of the Versa. As you can see, it is very nice and compact compared to a lot of the sample prep units out there. It is only 12 inches wide by 21 inches deep. There is a front sample compartment here. There are 2 panels on the sides. So that you can see there's access, you're able to get access to the entire instrument. For the most part, this front panel is used more for manufacturing here at TechMar, but we'll get a look at the inside. And the nice thing about this is that it's very easy. If you were to need to troubleshoot, you're able to get to any of the boards on the sides, and your pressurization valves and your vent valves are in the top here, and then we'll open this up, and this is your valve oven. Right here is your platen, sample vial cover, and your 20-position auto sampler. The only option for this system is the optional vial cover. There's no other, so there's no cryo-focusing. You can get it in a 115 or a 230 volt version unit, but as far as accessories or options, this is the only thing that's available. And one of the reasons that this kind of came out of, for those of you familiar with our 7000, it used to have a dust cover or protective cover over the top of that. And, for customers who are running in laboratories that may be particularly dirty or dusty, it helps to keep the tops of the vials very clean. The other thing is this unit, as you can see, will sit very low on the bench. It's only about 21 inches high as well. So it sits low on the bench. So the vials are more in range to the analytical consumer. So we've made this optional vial cover in order to protect the samples from any dust or dirt that may get on them, but also if you are running at high temperatures and you do require a safety lid, then you will be able to put this on. This is a picture of the 20-position carousel and a close-up of the platen oven. If we take the cover off of the platen oven, and I think the next picture will show you a close-up, hopefully you're able to see my pointer here. This is the sample needle. Everything in this valve oven is Silco or Siltec coated. So this is your sample needle. For those of you that are currently using a 7000, you'll be very familiar with this, as it is the same needle as the 7000. It's a single hole needle. And we'll go over some of the differences between the Versa and the HT3 in a few minutes. And one of those differences will be the needle. It has a standard 1 mil sample loop. When we were first designing this unit, if you can take a look and imagine this little rectangle here not being here. And this is one of the things where we sat in a design meeting and we were sitting around with the chemists and going, you know, that's a cold spot right in that area. So we were able to, without changing the overall design, we were able to add these little wings so that now everything on top of this oven is completely in direct contact and is heated at all times. Because we all know with Headspace or anything else, cold spots equal bad. So we're now able, you've got the arms of the, what I call the angel wings of the 1 mil loop. You are also able to get these in the same loop sizes that you have on the HT3 of the 7000. This is actually a 1 mil loop that is used on the 7000. So you're able to get the 250, the 100 microliter, the 250, the 500 microliter, and a 2, a 3, and a 5 mil loop if need be. You have the 6-port valve right here, and that'll be one of the differences between this and the HT3. As you know, the HT3 has an 8-port valve. And as you can see, you have the transfer line coming in here. So this is your sample line, and this is your carrier gas line. So if we take one of the panels off and we look underneath, for the HT3, it used to be that the carousel would move around and the vial would lower down through an elevator assembly into the platen. In this case, we have an elevator assembly, and if you can imagine that your vial is sitting right on top of this little ceramic piece right here, and this is what is actually going to mix the sample. So if you can imagine your vial sitting on top of here, this elevator moves up and will push the sample up into the platen where the needle is stationary. The other thing I would like to point out in here is on the back wall. You have your GCIO board and your main board. And these are very easily accessible from either side. If for some reason you needed to go in and check the lighting or to check to see if any of these connections were going bad, or if you needed to replace a board, you can take off the right panel and you've got full access to this GCIO board, or you can take off the left panel and have full access to the main board. This board on the bottom is your temperature board, and one of the other suggestions that came from the customers was, if you were to break a vial, and this compartment is very small, if you were to break a vial in there with liquid in it, how could you prevent to keep that from shorting out any of these boards? And so what we've done is there's a protective piece of protective coating on this board and also the power supply board over there. So they were just some of these things as far as feedback from distributors and customers. They may seem small, but every little bit of information that we received back really, you will notice, provides to the overall quality of the product. Some things were major changes in the software that just made it easier for the end user. Other things made it Something as simple as the Teflon gas line that goes in, that we're going to round that hole out a little bit bigger just so that we can, so that there's no kinking, or if you were to move it around, that you wouldn't possibly score that. There's small changes, but they're still changes that really add to the overall quality of the final product. This is a picture of the motor carousel, and this is what is actually moving the 20-position auto sampler above you. So in the previous picture, we saw the temperature board. If you can see, follow my arrow, that's right here, and that has that plastic cover over it. And then this is your power supply over here, and then your two main boards on the back. As you can see, there's not a whole lot involved in this instrument. It's very minimal in the way of electronics and moving parts. As for those of us that have to service our own instruments, we always go with less mechanical movement, the better. So there's a motor board for the carousel, and then there's actually one more small motor board, and that's literally the size of it. It's about 2 inches square. So the overall specifications are this. It gives you 20 sample positions for walkaway automation. It is a valve and loop configuration only. So in the HT3, you are able to do dynamic trapping. In a few minutes, I'm going to show you the differences between a 7000 and HT3 and the Versa, because there's still a lot of 7000 users out there, and I think this comparison will be good and help you decide which is the right instrument for your laboratory and your configuration. It is a single platen position only, so you cannot keep multiple samples at one time. It will only do one sample at a time. It runs 22 mil vials only. It's only 12 inches wide. It'll go from ambient to 200. It ships standard with a 1 mil loop. It has integrated mixing of low, medium, and high. The entire sample pathway is inert, including the transfer line, the sample needle, and the loop. It uses only a single-stage needle. It has built-in pressure control. So this is one of the major differences between the HT3 and the Versa, and I will talk a little bit more about that, because the HT3 uses a mass flow controller, the 7000 uses a flow restrictor, and the Versa, uses a little bit of both. You still have the capability of automatic leak check and benchmark testing. These are great tools for troubleshooting. The first thing that anyone, whether you call into tech support or you call me or you use any of our other instruments, purge and trap, anything, you want to do, if you're having issues, the first thing you want to do is run a leak check. Is everything tight within my system? Then you're going to run a benchmark. Is everything mechanically functioning? Are my boards working? Are my temperatures heating up? Are the carousel moving to the right position? So that helps us to eliminate anything mechanical before we go into working you with regard to analytical troubleshooting. It still has the method optimization mode, which is a feature in the software, and I'll discuss that more in a couple minutes. It uses the TechLink 2G software. It requires a USB connection. For those of you that have used any of our instruments in the past, we've always had an RS-232. If you've bought a new computer recently, you will notice that there are no COM ports on those computers. And a lot of customers do use laptops to run our software because it's basically just like a mini microprocessor for the Headspace unit or for the purge and track unit. So we've gone strictly to a USB connection, and don't worry, you get shipped with, I think, 5 meters of a USB cable, because there are some out there that have their instrument at one end and need to put their laptop or computer at the other end. So no problem with that. So there's no more RS-232, and it does not have the Ethernet capability. It still has standard and full 21 CFR capability for those of you that are running the USP 467. So this is a Headspace comparison for the 7000. That unit originally came out in 1990, and the HT3 came out in 2005, and the Versa was just released in October of 2011. So you can see the sample capacity differences here. So if you are a high throughput laboratory and you are running your samples through relatively fast, you're going to ask yourself the question, do I want to get a Versa or an HT3? And I want to make this clear that the Versa is not a replacement for the HT3. It's just an expansion of the product line. And it has its own place. Both of these have their own place in the market. So if you are a high throughput lab and you're running quite a few samples through on a daily basis, you are still going to want to go with the HT3. If you're only running a few samples, including your QC, or maybe if you are running 20 and you want to start it and you can still take some off and put some on the back end, then maybe the Versa would be for you. The Versa will only run 22 ml vials. So if you need to run other sample vial sizes, such as a 9 ml or a 12 ml, then you need to think HT3. For platen positions, once again, if you're relatively low capacity, then you're still able to run overnight or run over a weekend, and at that point you're not worried about, I've got to get so many samples through in an hour. If you are higher capacity, then you want that ability to use the GC cycle time, where you can say, all right, every time that GC comes ready, my Headspace is ready to do another injection. So you're going to need to be able to heat multiple vials at one time. For technique, the Versa will only do static. If you are looking to do lower concentrations or lower levels, so down in the ppb range, you are going to need to use the dynamic trapping capabilities of the HT3. There's quite a few customers and applications out there where you may be looking in the ppm ranges all the way down to ppb, into the lower ppb ranges. And that dynamic trapping gives us, it's kind of the idea of we used to use multiple Headspace extraction. All right, so you would equilibrate your sample, and then you'd have a cryo-focusing module on the inlet of your GC. And then you'd take an aliquot of that Headspace and send it over, and it would hold there with the liquid nitrogen, the cryo, about, say, minus 150 or whatever it's at. And then you would re-equilibrate and take another aliquot. In some cases, in some instruments out there, you can do this up to 9 times. Well, by the time you re-equilibrate and do that 9 times, that's a lot of time that's lost in the lab. Not to mention the cost that you're incurring using that liquid nitrogen. So if you ever have an option between, this has MHE is going to cost you a lot more time and a lot of money. Go with dynamic trapping. You are essentially equilibrating the sample and you are sweeping the entire Headspace and trapping it on some type of trap. And in most cases, this ships with a Vocarb, a K-trap, which is compatible for the majority of volatiles that most of you are looking for. So if you need to go low levels, you need to think HT3. If you're up in the higher ppm ranges and you only need a static analysis, Versa will work perfectly for you. Temperature limitations. The Versa will only go to 200, which hits about 95 to 98% of the applications in the market. There are a handful of applications that you will heat to 300 degrees. Examples of those are plastics and polymers. If you're looking for VOCs, outgassing from a polymer, and in order to get that polymer to release those VOCs, and you need to find the melting point of that polymer, in some cases you may need to go to 300 degrees. So once again, you can use the method optimization to determine what is the best temperature for your application. But if you only are doing anything less than 200 degrees and static, then Versa will work well, as will the HT3. They both use a 1 mil standard loop, and you have the others available. The 100 microliter, 250, 500, 2, 3, and 5 mLs. The mixing. The HT3 will go variable from 1 to 10. Most chemists, when they go in and they set up their mixing on an instrument, they set it at 1 or 5 or 10, which essentially equates to low, medium, and high. So that's what you will see with the Versa. You get these 3 range of speeds, and it has quite a bit of RPM power to it. It has great mixing capability. The needle size is a single-stage needle versus a dual-stage or a two-stage needle. The HT3 requires the two stages for the dynamic sampling, one to pressurize and one to take the sweep flow over to the analytical trap. So in the single stage, you're going to use it uses the exact same needle and is the exact same part number as the needle that's used in the 7000. For pressurization, the HT3 we use a mass flow controller, and in the Versa we use a pressure transducer. And for those of you, a pressure transducer kind of gives you use a 100 mil flow restrictor, similar to what we do in the 7000, but the transducer gives us feedback readings. So as an applications chemist, one of the things that I like to do when I'm setting up my schedule is to be able to look at my screen from wherever I'm at and be able to look at my static pressure, my vial pressurization, and my loop fill pressure. Because that tells me whether everything, and in most cases, whether it's working properly. Because I want to make sure those are stable from sample to sample. So the pressure transducer will give us that reading. It will capture it in the schedule, and you'll see, so for those of you that have the HT3 now, you don't see those columns. It only captures it in the history log. What we've done is added a few columns in the schedule, so now I can be standing in the room and be able to look, as I run a sample, what those pressures are, and then I can still go back into my history log and find them for later, and it'll keep them saved in there. The valving, we just need a 6-port valve because we're not doing any dynamic trapping on this, so there's no need for that 8-port valve. And the rest of these are pretty much, the sizes. Obviously, the weights are very different. Because this is only 12 inches wide and 21 inches deep, it only weighs 40 pounds complete. All of them have the method optimization mode software. And for those of you that have never used this, it is one of the best features for method development. If I ever have an unknown sample and I go into a customer site, I will always start out with this part of the software when I'm building a schedule. Because we all know with Headspace, the two critical factors in sample equilibration are temperature and time. As we increase temperature, we want to increase the number of area counts till we hit that equilibrium. If we get to a point where that temperature is too high, we could end up on a degradation part of the curve, which means the sample could be thermally labile, it could be degrading, what have you. But it will enable me, the method optimization mode enables me to program in the software that I want to run, start my sample, let's say at 50 degrees, and I want it to program and increment 10 degrees for every sample up to 200 degrees. And then I can come in the next day and plot my area counts. And then I want to take a look at time. As I increase time, I should also be increasing my area counts till I hit that plateau. And that's my equilibration, my optimum equilibration time. If I get to the degradation part of the curve, that means that part of my analytes are dissolving themselves back into the matrix. And I've let that sit in the vial too long. So this method optimization mode software enables you to automatically do all that. So all I have to do is come in the next day, look at my area counts, draw my curve, and say, draw a dotted line down. This is my optimum temperature. This is my optimum equilibration time. And you can do that with pressurization. You can do that with loop fill. If you have different static vial pressures, that might be something that you want to experiment with, because if you have a static vial pressure of 10 psi, you have to pressurize the vial at 2 to 3 psi higher than that. Otherwise, you don't have enough to transfer it over to the GC. If you go below that, you're never going to be able to push that sample out of the headspace. So you may want to be able to do some experimentation as to, where do I get my best, at what pressure do I get my best results? And it's, let's see, the 21 CFR, they all have that capability. So let's look at some of the target markets, and these are for both Versa and the HT3. So one of the main ones, as I discussed earlier, and part of the driving force behind this project was the residual solvents for the USP 467. So that's where we're looking at Class 1, 2A, 2B compounds in pharmaceuticals. Also the blood alcohol in the forensics market. A big one I'm going to talk about in a few minutes is the RSK-175, the dissolved gases in water. As we all know, that's becoming a big discussion in the marketplace. Another area is residual solvents in inks and packaging materials. My family owns a printing company, and one of the things as ink manufacturers and stuff that you need to make sure that once those inks are printed on the packaging materials of food that we're ingesting, that you want to make sure that none of those residual solvents are leaching out into that packaging or out into that food. And that seems to become is a growing market, not only for those that are actually manufacturing or printing on the plastics, but also for the ink manufacturers, so that they know what the level of the solvents are in those inks prior to them leaving their facility and getting out there. So this is, in some cases you might think this is a high temperature application, but it's not. Most of these are done somewhere between 80 and 100 degrees. And we have a couple good application notes, and at the very end I'm going to take you to the website and show you where everything is. For R&D, the method optimization mode that I just talked about with regard to the software, it's one of the best tools that you can use. A lot of people seem to fear using it, but in the Versa you will find that we've added graphics in there so that you can get a graphical representation and pictures of exactly what you're doing, so it makes it a lot easier to use for the end user. Environmental screening, method 5021, which is goes way back in my early days at Techmar. In 1996, we spent a year working with the EPA on this method for screening of environmental samples prior to by Headspace prior to running them on purge and trap. And it was supposed to be a quick screening method primarily for soils, so that you would not overload your purge and trap system by putting a soil on there that was in the high ppm ranges. So a lot of laboratories are still using this today, especially if they run a lot of soils. So virtually any application with an HT3 can be done using the Versa if you're in a static mode and you're running at less than 200 degrees. So I'm going to escape out here now real quick to some data that we have run by my good friends at Phenomenex out in Torrance, California. And we're going to look at some of the residual solvents data. So the first setup here are the water-insoluble procedures. These are the Class 1s. And there'll be an application note out on this. But for the sake of time, I'm going to go through this rather quickly. But we're looking at the Class 1, and we're trying to look at that. We want the RSDs definitely to be below 15%, but the goal was to try to get them in the less than 5% range. The other thing that you want to keep an eye on with regard to your residual solvents is your signal-to-noise ratio of your compounds. Especially, for the 111 needs to be above 5, and the remaining compounds of the Class 1 need to be above 3. So this is the first chromatogram is the Class 1 compounds, and these are 5 replicates that are overlaid on the chromatogram. So there's your Class 1 compounds. And these are your water-soluble 2As. So so you can see the RSDs across all those compounds. This is N equals 5, reproducibility study here. And the big thing we want to make sure is the resolution between acetonitrile and dichloromethane that you can see right here between these second and third peaks. And then your procedure, your Class 2Bs. Now, the next thing I want to take a look at, let me go back to my slideshow. Bear with me just a second. All right. So this is an example of blood alcohol analysis. If you go onto, and I'm not going to spend a lot of time on this, if you go onto our website, you can pull up an application note on both the HT3 and the Versa. This was done on a Phenomenex BAC1 column, and this particular chromatogram here was done on the Versa as well. Now, the thing I want to just spend a few minutes on, because this is becoming one of the big discussions, the EPA, and they call it, you know, as we said, we talk about the fracking or the fracturing. This was in MSNBC, this was back in December. And then this was an article that I found over the weekend. It's called Living with Fracking, Where the Water Catches Fire. And this was in the this week's issue of People magazine. So that brings us to the discussion of hydraulic fracturing. And for those of you that are not familiar with it, because I remember we started looking at this about a year ago, and many people have been running what they call the RSK 175 for a long time. But it's the drilling process that helps recover natural gas from your sources like coals and your shale formation. So many of you you've heard them talk about the Marcellus Shale, and there's a lot of stuff happening on the East Coast. We have been working with the Pennsylvania Department of Environmental Protection for, probably going on the last year. And we will be having a webinar on that soon, I think at the end of February, where we're going to be looking at doing that by purge and trap as well. But for today, I'm going to talk about this process. So what we did was we're running a side-by-side comparison in the lab on the HT3 and the Versa, and these are just some of the parameters. The HT3 paper is in final review and should be up on the website within the next week, and I do have some Versa data that we pulled off that we've been running this week. So these are just the parameters that we used, and I'm going to let you'll be able to read that in the paper. I want to get to the actual summary of the data. This is a chromatogram, looking at the separation of methane, ethene, ethane, and propane. And this is a summary of the linearity in RSDs for just these compounds. So if you look at the HT3 and the Versa, you can see very well that we're very close in linearity and also very close in percent RSD for running these samples. And that's what we want to be. We want the Versa and the HT3 to be compatible, meaning that you want to be able to get the same results whether or not you use an HT3 or a Versa. The main difference is one uses a mass flow controller and one uses a pressure transducer. Regardless, you're still working in terms of pressurization of a vial. So I want to thank you. I'm sure I'll have some questions that I'm going to look for. But I do want to take you real quick to the TechMar website and just show you, if you go to www.teledynetechmar.com, you will see that you will be able to get to just about anything. And if you go to applications, it'll give you the two latest applications. We've released one on QC, and there's also a comparison of VTEXs and olive oils by HT3. So doing some food and flavor analysis. Pretty soon the RSK for HT3 will be up here, along with the one for Versa. We are going to be at PickCon, and I'm sure Betsy is going to have some information coming out on that pretty soon. We have 6 posters that we're presenting there. One of those is going to be looking at the USP 467 and analyzing all those compounds on the Versa and the HT3, looking at helium versus nitrogen. A lot of people are wanting to move to nitrogen, mostly for cost effectiveness reasons, and we just need to be able to show that, even though in our mind and theory says pressure is pressure, you just want to be able to show that we're getting the same results with nitrogen as we are with helium. If you need to reach anyone in sales or service, please click on these buttons here, and this will take you to any information you need. Here's our technical support, so techmarsupport@teledyne.com. And please feel free to use the 800 number to call into our tech support. Most of our tech support engineers have been here for well over 10 years, and they have a plethora of instruments open in cubicles, and they've got headsets where they're able to walk around, and they can talk you through just about any problem that you're having. And they will try to do that before you need to open a service call. They have many years of applications experience as well. So I please encourage you to take advantage of this resource that's available to you as a TechMart customer. If you have any, and you would like to get any information from regarding the Versa or the HT3 or any other TechMart products, you can come to this site. Missy Gibson is the domestic field sales manager. I'm sure all of you know pretty much Mr. Tom Hartline. And Tom Rohrkemper is our international tech support manager. Kevin is our international sales manager, and there you can find myself. So if you ever, are unable to find my card or want to send an email, you can go directly to our website and click on this, and it'll take you right to there. So I'm going to look and see if I have any, I have some questions. All right. Let's see. Some of them look like, are there any other questions? Most of these are just initial audio that they might have had in the beginning. Does anybody have any specific questions regarding the Versa or the HT3 or anything else at this time? Please feel free to go ahead and you can also email me at treller, R-E-L-L-A-R, @teledyne.com, or you can go to the TechMart website and also find me in the sales. If you think of questions that you have afterwards, or if you want to discuss anything that you might have any questions regarding your application, please feel free to email me or give me a call. All right, well, thank you, everyone. Please, if you have any questions, most of these were kind of questions that were sent to me privately, so feel free to give me a call. Sometimes you have to think about it and process the information, and I hope you enjoyed it, and if you would like to recap and listen to it again, it'll be available again in a week. Thanks, everyone, and have a great day, and I hope to get out in the field and see some of you soon.